This is R.D. Sharma Solution, Class 12, Chapter 10, Differentiability. VSAQ, very short answer questions. Define differentiability of a function at a point. So, we have heard a lot about differentiation, but all it comes from whether it is differentiable or not. Then only differentiation you can do. But everything starts with continuity. Okay. So continuity, if the function is continuous, we can check for differentiability or non-differentiability. So differentiability means a point when we go to the left or right, the tangent or the point of contact of a line, or though the line should be only one. For example, if I draw a line here, if I want to check the differentiability here, then the from positive x-axis, the angle m tan theta dy by dx del y by dx, this is called the differentiation, and the possibility of just one tangent, not two tangent at that particular point, is called that this function is differentiable. For example, if you have certain situation like this, you have a point to check and you get two tangents at a point, just on the left hand side and right hand side. That is called the left hand limit or right hand limit. In the case of differentiability, we call it as a left hand derivative and right hand derivative. Okay. So how do we write it? The basic idea is the base is a function. So you call it as a function, that if a fx, a function, it be a real valued function, and this is defined on an open interval a and b, this is a, this is b, and then you choose, or you are given a value c, that at point c you have to check, and this c is belonging to a and b interval. Then at x equal to c, if this fx function is differentiable or derivable, or it has a derivative at x equal to c, then limit extends to c, fx minus fc, of course c is the point where we have to check, fx minus fc divided by x minus c. This expression is the derivative, or it is called as f dash c, and this function, this whole what I have written in the brackets, should be finite, that is, should not be form of any of the form which I am writing. It should be unique, it should give you a proper value, not undescribable or indeterminate value. That is called the derivative, and differentiability is given by the finiteness of this expression. Okay. Is every differentiable function continuous also? See, continuity is all about not picking up your hand and drawing something without a chance of picking up your pencil or a pen. For example, this I am making, okay, I am going through that graph over it, and I don't have to pick my pen up. That is, there is no break. If you can understand by this example that you are on a trip and there is no break. This is a continuous road. There is no breakage. There is no traffic jam. There is no bridge being already fallen off. So when you talk about differentiability, see, differentiability is not what we learn in continuity. Differentiability is all about the slope of that particular point. That is, if that point, if you go on the left, little bit left, a little bit right, and you get two different tangents at that point, we say that no, this is not differentiable. If you go left and right, that is, if you want to check at c, then c minus h, c plus h, you find out, and then both the value at this c minus h and c plus h both have the same tangent. that is same value m tan theta dy by dx or y by x or del y by del x, all of it, then we call that the function is differentiable. Okay, there may be functions which are continuous which are not differentiable. Okay, we'll take the example later on. But yes, if a function is differentiable at a point, then it is necessary that it has to be continuous. That is, continuity is not the guarantee that the function can be differentiable or not differentiable. The function can be differentiable, it cannot be differentiable. But the differentiability is a guarantee that the function is continuous. Okay? So continuity describes differentiability, whether it is yes or not, but differentiability guarantees the continuity. The question is asking only about yes or no, so you can stop here. But if you want to prove it, then also we have different options to prove it. I'll just prove it. Okay. So for that, let us consider a function fx, and it is differentiable at x equals to c. Okay. Let us take this point c. Then what is the definition of differentiability? Limit x tends to c, fx minus fc divided by x minus c. This expression should exist finitely, and then we call it as a f dash c. Basically, it's a differentiation only. By first principle, you can call it. Okay. So, in order to prove that fx is continuous at x equals to c, which I have just taken in that graph, left-hand graph, it is quite sufficient to just show that limit x tends to c fx is equal to fc. If you put the value of c in fx and you get a value fc, then it is continuous. That is, you don't have any break. Everything is smooth now. So that is, this thing is sufficient in order to show. Okay. That is, limit x tends to c fx. If you apply this limit on a function f, and then you get fc, that is the value of the function, then you get the continuity. So let us see how to prove it. See, we have limit x tends to c fx. This is how, this is what we have to judge, and we will finally prove it to be fc. That is the value of the function at c. So you have fx. See, fx, what is fx? And we will introduce some f dash x here. Just I'll show you how we are going to do this. I am adding and subtracting fc. It will not have any effect. You can just cancel this fc. So this fx can be written as fx, this fc I am, negative fc I am bringing in front, and a positive fc I am taking later. So fx minus fc, you can multiply the numerator and denominator by any number. Why not to multiply by x minus c? So x minus c in the denominator, x minus c in the numerator, it will be cancelled out, and you have fc already there, right? Now let us apply the limit here. When you apply the limit, we just started with fx, we have not done anything else. So limit x tends to c, it will go to each and every value. Here also, limit x tends to c, everywhere. Well, this limit x tends to c on a constant will not work, but still, you need to show that limit x tends to c has to be there. So this fx minus fc by x minus c is nothing but f dash c. Limit x tends to c in x minus c will be what? If you put x as c minus c is 0, plus limit x tends to c fc. Since fc is a constant, whatever limit you put, it doesn't matter. For example, if you have limit x tends to 2 and you have a 5 value, where are you going to put the x? It will always be 5. So just keep it as fc. F dash c into 0, anything with 0 will be 0. So you get fc. And what did I tell you in the beginning? that if limit extends to c, fx, if we can prove it to be fc, then it is sufficient for us. So we have proved it. Fx is continuous at x equal to c. You just have to do or prove this, and that will be sufficient. Is every continuous function differentiable? So we just discussed it now. Every continuous function, it can be differentiable, it cannot be differentiable. We don't know that. We have to check. But if a function is differentiable, then the function has to be continuous. Continuity is not the guarantee that the function is differentiable or non-differentiable. But differentiability or having a differentiation or having a derivative is the guarantee. For example, if you take a staircase, continuity come first, then you climb up to differentiability. You don't go first differentiability and then come to continuity. It is always continuity first, then you go up to differentiability. If you have reached differentiability, that means you have already achieved the continuity. Okay? So this example is a very well-known example which we have so many questions on modulus x which we discussed. So y equals modulus x is a classic example of a function being continuous but not differentiable. A function or a graph of the function, if it can be drawn without break. See, if you have a car and this is your track, you don't have to stop. You just have to take a left turn here and just move along. That means you will not have any break in your journey. So this is continuity. But since the peak here is a sharp edge, and if you take on left and right some point, and if you want to draw a tangent, the slope of the tangent at these 2 points are different. That means this function will not be differentiable, because at particular point we have 2 different tangents, and that we doesn't want in differentiability. Give an example of a function which is continuous but not differentiable at a point. This is just what we have seen, and we'll prove it just now. And continuity and differentiability you can prove easily. So we have done this question all through. So y equals to modulus x you can have. See, if you have a line y equals x, this is a simple line which is passing through the origin, y equals x. When you take the modulus, that means you cannot have a negative value, a negative y value. So negative y value can only be made positive when you multiply negative with a negative. So this line, the below line, has to go up. That is how the definition of this function has come. Y modulus x, it will be x if x is greater than or equal to 0, or minus x if x is less than 0, because once you are below, there will be a negative value. So in order to make it positive, because modulus x will always give you a positive value, in order to get a positive value, you have to put a negative in front of it. That is how it is negative x. Okay? So this modulus function or mod function is continuous at x equals to 0, but it is not differentiable at x equals to 0. I hope you will be able to do it. Okay? So 10.1, 10.2, there are so many exercises, so many questions we have done, and there were more complicated questions we have covered, because it was modulus of log of modulus x. That also we have completed, right? So I'll just give you a hint. Y equals modulus x, as I just said, will be x if x is greater than or equal to 0. It will be negative x when x is less than 0. So negative x, x is 0. There is a slight correction I'll make just now. So x equals to 0 will check, left hand limit and right hand limit both we are going to check. We'll go a bit on the left of x equals to 0. So we'll write 0 minus h. H is very small number. X is 0 plus h. So we just go ahead. Okay. So left hand limit that is x is less than 0. So you have to take negative x here because you are on the left hand side of 0. So it is going to be minus x, negative x. So minus x. Here you are going to take a positive x, of course. Positive x. The function is done. Now you can apply the limit. So x has to be replaced by minus h. So minus minus h is plus. And here you have to replace x by h. So you have a h. So limit h tends to 0. These are a limit h tends to 0. This is limit. So you have a h here and h here. Limit h tends to 0. So you get a 0 here. You get a 0 here. So it is continuous. This modulus function is continuous. But you can easily prove that it is not continuous, as we have done in the previous discussions also. So I want you to do it by yourself. But I will give you a reference also. You can just have a look here. If you have any problem, just have a look and refer to it, because we have already done. So I am just giving you a hint that it is, you will find it as not differentiable but continuous. If fx is differentiable at x equals to c, then write the value of limit x tends to c fx. So if it is differentiable at x equals to c, then write the value of limit x tends to c fx. Remember, just we did a question a few minutes back and we proved a limit x tends to c fx is fc. We just proved it. Okay. If fx equals modulus of x minus 2, write whether f dash 2 exists or not. So we will just do the classical solution. So let us do it. Basically it is y equals x minus 2. It's a line. Okay. So x is 0, so y will be minus 2, and y is 0, so x will be equal to 2. So this is just a kind of line I am making. It is not actual line. Okay. I am just making a line. I am just saying that there will be no negative in the below y. It will go up. That's what I wanted to just tell you. So this f dash 2 is basically finding out the derivative at 2. So modulus is what? Fx, if modulus x minus 2 is there, it will be positive ahead of some value and negative below that value. When with y was modulus x, it was the 0 point, which was the point dividing the negative and positive value. When you have x minus 2, just put x minus 2 equal to 0, that is x equals to 2. 2 is the dividing point. All the values above 2 are going to be positive, and all the values below 2, they are going to be negative. So when x is greater than or equal to 2, you are going to get positive x minus 2. When x is less than 2, you are going to get negative of x minus 2. I hope you got this idea. So in order to prove, or in order to find out whether this f dash exists or not, let us find out the f dash using the classical left hand derivative and right hand derivative. The left hand derivative, right hand derivative, I'll just change minus x minus 2 to 2 minus x. So x is equal to 2. So x equals 2 minus h, x equals 2 plus h. So going on the left and right, that's what we are doing. So f dash x will be equal to fx minus fc by x minus c. Fx minus fc by x minus c. What is fx? When you go on left, this function you are going to use x less than 2. So it will be 2 minus x here. And what will be the value of f2? See, if you put, this is the equality sign, okay? So when you put f2 in x minus 2, it will be 2 minus 2, that is going to be 0. So I am placing 0 here, but let me tell you f2 is 0 divided by x minus 2. So 2, let us replace x by 2 minus h here. 2 minus h minus 2, so it will be negative h. And 2 minus, here also I am replacing it by 2 minus h by minus h. So 2 minus 2 plus h, 2 gets cancelled. You have h divided by negative h. So h gets cancelled, you get a negative 1. And please remember, everywhere you have to write limit h tends to 0. I'm not writing it, but you have to write it on every step. Now x greater than or equal to 2, so you have to use a function called x minus 2. So x minus 2 minus 0 divided by this, of course, x minus 2, so 2 plus h minus 2, you have h. In place of x, replaced by 2 plus h minus 2 divided by h, 2 gets cancelled, h gets cancelled, you get 1. So the limit h tends to 0, 1, limit h tends to 0, here negative 1. So they are not matching. You can easily say that f-2 does not exist. So most of the questions, they are repetitions, which we have already done. So you have to go through this 10.1, 10.2, etc. exercises. Write the points where fx equals log x is not differentiable. We always talk about mod x and multiple variations of modulus function. So the solution is in front of you, but understand it very carefully. You need to understand the graph of log x. Until you understand this graph, you won't be able to solve this. Because this graph is crossing the x-axis at 1. So above 1 it is positive and below 1 it is negative, right? The y value, the y-axis if you take. So when you take this modulus, it will always give you a positive value. Modulus means that. Modulus sign means, or that function means always positive value. Okay? So from 0 to 1, if x is between 0 to 1, y is negative. You can see the negative y-axis here. It is going down. So you have to introduce a negative to make it positive. So modulus of anything will always be positive. Please remember, that is very important. So in order to make negative as positive, we have to introduce a negative, because negative into negative is positive. And once you go ahead of 1, that is 1 to infinity, which you see in the graph also, the graph is positive. For any value of x above 1, it's positive. So first we have to make the function so that we can actually go to the differentiability. So log x, this is going to be modulus of log x will be, if it is between 1 to infinity, or you can just say x is greater than or equal to 1, because log 1 is 0. There is a proper legal value for log 1. Okay, but log 0 is not legal. If you see this graph, it is not going to ever touch the y-axis. So that is why it is x is greater than or equal to 1. It is going to be log x positive. But between 0 and 1, if you see here, it's going to negative. So you have to introduce a negative in front of log x in order to make it positive. So between 0 and 1, please remember 0 is not inclusive. 1 we have already included in the above one. So it will be between 0 and 1. Non-inclusive. So this is modulus x. I have not placed modulus x on the left side. Just assume it to be there. So we have to check where x equals to 1. So we will find out the left hand derivative and right hand derivative for x equals 1. So always remember, I show the solution just because you need to know how to write in your examination. Because the way I teach, I don't write everything. Okay? One by one. Otherwise it will take a lot of time. So if we are, on the left hand side of 1, or we are on the right hand side of 1, we take 1 minus h and 1 plus h. So when you are on the left hand side of 1, what function are you going to use? It's going to be negative log x. Okay? The derivative, or you can say differentiability test, is fx minus fc by x minus c, limit x tends to c. This has to be a uniquely finite value. It has to be a finite. It should exist. So x equals 1 minus h. So minus log x we are going to use in place of fx. Okay, c is what here? We are checking at 1, so it is going to be 1. What is log 1? fc is log, because fx is log x, modulus of log x. So if you put 1, log 1 as I just said is 0. So it will be 0, fc is 0, f1 is 0. X minus cx, that is 1. C is 1 here. Now you have to write it as limit x tends to 1 minus, that is, it is just indicating you are on the left, checking on the left of 1. That is deciding which function we are going to use. Similarly here, x equals 1 plus h, but we have to show the examiner that you are going on the right of 1. So you have to use x tends to 1 plus. So when you are above 1, which function are you going to use? Log x. Again, fx is log x. Fc is of course 0, which we have just done. X minus c, of course, x minus 1. C is 1. All things remain the same. Only the function fx changes. So now the limit will be changed because we are replacing x by 1 minus h. Here also limit h tends to 0, we are replacing x by 1 plus h. So minus log, in place of x, replace it by 1 minus h. And then this x has to be replaced by 1 minus h minus 1. 1 gets cancelled. Negative h it will be. Here log, in place of x, replace it by 1 plus h. In the denominator it is x minus 1, x is 1. So 1 plus h minus 1, 1 gets cancelled, it is h. Now please remember, limit h tends to 0, log 1 plus x divided by x. You can have anything, normally we do it like limit theta tends to 0, log 1 plus theta by theta equals 1. So this is log 1 plus h by h, same as the, the identity. So just make it as 1. Here also log, you can write this 1 as 1 plus minus h divided by minus h. So 1 plus x by x form. Okay. And since we have a negative outside, this negative, so you can just take it outside and limit h tends to 0. So it is of the same form, log 1 plus x by x. So this is going to be negative 1. Negative 1 and 1, they are not matching. That is the left hand derivative and right hand derivative, they are not equal. That means fx is not differentiable at x equals to 1 because of the dissimilarity of the left hand derivative and right hand derivative. Okay. Write the points of non-differentiability of log modulus x and modulus of that. So this question we have already covered. It was around 15 to 20 minutes of discussion. Exercise 10.2, question number 9. And this question is going to get repeated in the MCQ also. I'll tell you, there also. It is going to be around 15 to 20 minute discussion, the solution of that. We have already done this. So I would encourage you to just watch 10.2 exercise, question number 9. How this has come, I have explained it in great detail. And if you want to do it again, you can just do it. Okay, and take a reference here. Write the derivative of fx is equal to modulus of x whole cube at x equals 0. So here we have mod x. It can be of any power. Any power. So there is no catch or trick in this question. This is very simple question. Modulus x is simply x when x is greater than or equal to 0. It is going to be negative x when x is less than or equal to 0. The way we have been doing the mod x, same thing. Just cube it because it is modulus x cube. What are you going to get? X cube is x cube. And negative x cube, always negative to the power of odd will always be negative. So negative x cube. So write the derivative. So how are you going to find out the derivative? You can do it using the left hand derivative and right hand derivative. The values are going to same. Okay. Now the question is saying what? The question is saying write the derivative of fx. It was not being said check the derivative or find out the differentiability of this function. It is not being told. Just because we are on the chapter of differentiability, that's why we have to do like this. But in the examination, there will be no chapter-wise question. It will be simply write the derivative. So it is simply first principle fx plus h minus fx by h. You'll see the answer will come same as what the solution I have provided you. Okay. So which function we are going to use? We are going a bit front of x, or you can say on the right hand side of x. So you will take it as x cube and minus fx is what? It is already x. Fx, it is going to be x cube. Fx is x cube only. and divided by h, and this is x plus h whole cube actually. So I'll just open it. So x plus h, fx plus h is x plus h whole cube, and minus x cube, a cube plus b cube plus 3ab, and then a minus b, that is a cube plus b cube plus 3a square b plus 3ab square. This is just a hint I am giving. This is also a way to solve. X is a and h is b. So x cube plus h cube plus 3x square h plus 3x h square minus x cube, it is h. Limit h tends to 0. You can just cancel these x cube. And here you can take h common. H square plus 3x square plus 3xh. I am taking h common from all of these terms in the numerator. H, just cancel these h. And apply h tends to 0. This is 0. This is 0. 3x square it is. Okay. So now this is your answer. This is your derivative. But you have to find out the derivative at x equals to 0. So f dash x or f dash, the function of the derivative is 3x square. So this is f dash x. The first principle was basically f dash x. It is 3x square. Put x as 0. It is 3 into 0 square. That is 0. And those who are, this chapter is differentiability. So you have to do it the way the answer has been shown, displayed to you. Okay, this is what has to be done in this chapter. But when it comes in the examination, then it will not be said that, okay, this question has to be done using the theorems and identity of that chapter. No. This is how you are going to do it. So both ways you can solve it. It's one and the same thing. But the question is about the derivative, not the differentiability. Write the number of points where fx equals to mod x plus mod x minus 1 is continuous but not differentiable. Okay. So if you just go to 10.1 exercise, we have done this question number of times. Okay. See, there is one more question coming which is of almost same size or say same logic. Almost, not exactly. So this type of question we have done already. So you just have to refer to 10.1 exercise. Then you will see that 3-4 questions were there like this. We did it. Okay, so I hope you'll be able to do it. But I will give you a hint. Those who want to do themselves, I'll give you a hint. First of all, mod x. When it is 0, always we check where the function is going to be 0. It is x greater than or equal to 0, x when x is greater than or equal to 0, negative x when x is less than or equal to 0, less than 0. What is mod x minus 1? When x minus 1 is equal to 0, x is equal to 1. So there are 3 intervals here. One is from negative infinity to 0, that you can call it as x less than 0. Then we have between 0 and 1. Then we have the value which is 1 to positive infinity, or you can just call it as x greater than 1. So at what point, what function has what sign, because it is modulus. So those function has to be used while you are doing the continuity check and the differentiability check. Right? Because if you are following me all through this chapter, you know how we have done it already. But those who are just watching this exercise, then for them, this is very important. We always tend to make intervals, and because of these intervals, the continuity and the differentiability at point x equals to 0 and x equals to 1 has to be checked. These are 2 points. So let me just give you a basic idea that how we actually formulate the final expression that has to be used in the continuity and differentiability. So this is 0, this is 1, we already explained it. So modulus of x plus modulus of x minus 1 we have to do. If x is less than 0, that means what? We are on this side. So modulus x will be negative x, because of course below 0 mod x is negative, and below 1 modulus x minus 1 is negative. So we are talking about below 0. So if it is below 1, below 0 it will be. So it will be negative x minus 1. When we are between 0 and 1, see, always we take the equality here. because mod x is all about equality. Equal to 0, it will be positive. So when you go up between 0 and 1, so mod x becomes positive now because you are up 0. But you are still below 1, which is the deciding factor for the negativity of x minus 1. So it will be positive x and negative x minus 1. When you go up 1, when you go above 1, you are already above 0. For that we have modulus x as positive x, and modulus x minus 1, because you are already above 1, it will be positive x minus 1. Okay. So what do you get finally? Minus x plus 1 it is. Then x minus x plus 1 will be. Then we have x plus x minus 1. So this will give you minus 2x plus 1. This will give you 1. This is going to give you 2x minus 1. So this is x less than 0. This is x between 0 and 1. Equality, 0 has to be equated here, and x is greater than or equal to 1. Now these three functions are very important to formulate. Now you have to check the continuity and differentiability by yourself at 0 and 1. I hope you will be able to do it. If you have any problem, just go to 10.1 and refer to those questions, which are these: modulus x and modulus x minus 1. So all these exercise we have been doing this question. Okay, this just I told you because we are going to do a question like this just now. If limit x tends to c, fx minus fc divided by x minus c exists finitely, write the value of limit x tends to c fx. So the same exercise which we are doing, question number 2, question number 5. Both the questions I told you how to solve it. I actually solved it for you. So this, what is the value of limit x tends to c fx? It is going to be fc. That we already proved. So just refer to that question. I hope you will be able to refer it. Okay, you just have to go to that question and see how we solved it actually. Write the value of the derivative of fx equals modulus x minus 1 plus modulus x minus 3 at x equals 2. So this we are going to do. Okay. Now this modulus, please just see where this function is, where it is going to be 0. So x minus 1 equals 0 and x minus 3 equals 0. So x minus 1 equals give x equals 1. X minus 3 equals 0 will give you x equals 3. So you have to check at 1 and 3. But the question is saying something else. It is saying at x equal to 2, which is between 1 and 3. So first interval is below 1, negative infinity to 1. Then we have 1 to 3. This is the second interval. And the third interval is from 3 to infinity. So x is less than 1, x is greater than 3, and between 1 and 3. There will be 3 intervals. So this x minus 1, if it is this will be negative. On the left of 1, x minus 1 will be negative. On the left of 1, x minus 3 also will be negative. So negative x minus 1, negative x minus 3. Alright. Between 1 and 3, because you are above 1, so x minus 1 will be positive, but x minus 3 will be negative. So this will be positive, this is going to be negative, because yes, between 1 and 3. Now, x greater than or equal to 3, so you are positive for x minus 1 also, x minus 3 also. So just put positive here. Okay. So now let us just solve this, and then we'll use these final functions to actually find out the derivative at x equals 2. So minus x plus 1 minus x plus 3. This is going to be x minus 1 minus x plus 3. X minus 1 plus x minus 3. This is going to be minus 2x plus 4. This gets cancelled. 3 minus 2 is 2. And 2x minus 4. This is for x less than 1. This is for x between 1 and 3 inclusive of 1. And this is going to be x is greater than or equal to 3. Okay, I hope you got the idea. How did we get this answer? Now, we will check the differentiability not at 1, not at 3, but at 2. The question is not asking about 1 and 3. It is asking about 2. But What do we do? What do we do in the actual scenario? We go to left, put x2 minus h. We go right, we put 2 plus h. Try to put the values in fx minus fc by x minus c. This is what we do. Fx minus f2 by x minus 2. Because we have to check at 2. So limit extends to 2 here. So you can do like that. Put 2 minus h, 2 plus h, and you'll find out the value. I hope you'll be able to do it. Since I have already showed you 2 minus h, I will tell you how to put this 2 plus h. That is the left hand limit and left hand derivative and right hand derivative we are going to do. Both will give you same answer. So f2 plus h I am going to put minus f2 divided by 2 plus h minus 2. Limit extends to h tends to 0. Now f2 plus h, you are here, that is just a bit ahead of 2. What is the value of between 1 and 3? It's a constant value. It is a 2. f2 plus h or f2 minus h will be 2. What is the value of 2? f2. Of course it will be 2. But we will check it. f2 is modulus of 2 minus 1 and plus modulus of 2 minus 3. I know the value is 2, but just to show you that this will be 2, I'm just trying to show you. Modulus 2 minus 1 is 1, plus modulus of minus 1, 1 plus 1 is going to be 2. So 2 minus 2 divided by this gets cancelled, you have h. So 2 minus 2 is 0, 0 by h is 0. Okay? So this is how you get the value. You go to left, right. If you don't want to do it this way. Because the value between 1 and 3 is a constant. It's 2. So it will always be 2. If fx equals under root x square plus 9, write the value of this. So it's a very straightforward question. There is no trick, nothing. Just solve it the way we have been solving the question. So I'm not writing all the steps. That's why I show you always the solution so that you know how to write it. So this is under root x square plus 9. Fx is, I'm replacing fx by this value. Minus f4. What is f4? Under root 4 square plus 9. 4 4 is 16. 16 plus 9 is 25. 25 under root is 5. Actually it is plus minus, but we'll keep it as 5. Divided by x minus 4. Okay. Now there is no way to solve it now. Limit extends to 4 it is. So we have to rationalize it. So let us rationalize it. Multiply numerator denominator by the positive of the numerator. So under root x square plus 9 plus 5 divided numerator denominator. You have a square minus b square, because a plus b, a minus b is in the numerator. The under root x square plus 9 whole square is x square plus 9 minus 5 square. You have x minus 4 under root x square plus 9 plus 5 it is. Okay, those who want to do by themselves, the answer is here. You can just have a look. Or those who are following me, just take the next step now. So just open it now. X square plus 9 minus 25, x square minus 16 it is. X square minus 4 square it is. X minus 4 into x plus 4 it is. So you have a minus b, a plus b. X minus 4, x plus 4, just you can write it here. So I'm just replacing it by x minus 4 into x plus 4. And this all is going with limit, this x tends to 4. Okay. It is not what I have written. It is actually limit x tends to 4. Now you have this limit, because I cancel x minus 4, x minus 4. So now this x 4 plus 4, I'm replacing x by 4. This is 4 4 is 16. 16 plus 9 is 25. And root 25 is 5. So this is 8 divided by, this is going to be 5 plus 5. It is going to be 10. 8 by 10 is 4 by 5. That is going to be your answer. 4 by 5 is your answer. Okay, those who have already done, this is 4 by 5. Okay, this is all about this exercise. Thank you so much and take care of yourself.